Good day, friends. I'm welcoming you to another session. Today, we shall be handling two concepts: heat and temperature. Heat on its own is a form of energy known as thermal energy. By definition, it is a measure of the total internal energy of a body. From our common experience, we see that hotter objects tend to get colder, while colder objects tend to get hotter when they are placed together. This is because heat usually flows from region of higher temperature to region of lower temperature and not vice versa. Therefore, this transfer of heat from one point to another is actually due to difference in temperature between the 2 points. Then what is temperature? Temperature, simply as we know, is the degree of hotness or coldness of a body. When an object is heated, the temperature rises, and when an object is cooled, the temperature falls. Temperature is measured with an instrument known as thermometer, while it is measured with an instrument known as calorimeter. The unit for heat is joule, while the unit for temperature is degrees Celsius or Fahrenheit. Talking about heat transfer, there are three ways by which heat can be transferred. We have conduction, convection, and radiation. Summarizing these three methods of heat transfer: conduction, convection, and radiation. Treating conduction first. Conduction is simply a method of heat transfer in solids, whereby heat energy is being transferred from a region of higher temperature to a region of lower temperature, while the average position of the particles of the material remains the same. In conduction, a material or a medium is needed, yet the molecules or the particles contained in this material do not need to move to transfer the heat. They actually vibrate around the mean position. To understand this very well, let's create this picture that you have your tea in a cup, maybe an aluminium cup, and then you dip your silver spoon inside this cup. What happens? Within seconds, you observe that the handle of this spoon gets real hot. This is simply conduction. The heat has been transferred from the hotter body, which is that aluminium cup containing the hot water, to the colder body, that is the spoon. Yet the water did not move. When that the temperature, or that the heat, has been transferred from one point to another, while the average position of the particles still remains the same. Materials that conduct heat perfectly well are known as conductors, while materials that do not conduct heat are known as non-conductors or insulators. Taking the second method, convection. What is convection? Convection is a method of heat transfer, whereby heat is being transferred in gases or liquids by the actual movement of the heated fluid from a region of higher temperature to a region of lower temperature. In convection, unlike what happens in conduction, you will observe that heat energy is being transferred by the actual movement of the heated fluid. Convection is seen at home, especially while boiling our water. Water boils by convection. Also, when you on your heater at home, the room gets hot by convection. It is also seen in nature, in land and sea breeze. The next method is radiation. Radiation is a method of heat transfer by which heat is being transferred from a region of higher temperature to a region of lower temperature without requiring a material medium. In radiation, no material medium is required, unlike what we see in convection and conduction. For instance, the heat of the sun reaches the earth by method of radiation. Also, when you sit by the fireside, maybe during the harmattan, you are trying to get warm, you see that within a period of time, a very short period of time, your body starts feeling warm. This is by radiation. So simply, in convection, we require material medium. In conduction, we require material medium. while in radiation, a material medium is not needed. In conduction, there is no actual movement of the heated molecules or material, while in convection, the heat is being transferred by the actual movement of the heated fluid, while in radiation, no medium is required at all. Having known the methods of heat transfer, still remembering that temperature is a degree of hotness or coldness of a body. Then we have scales, temperature scales, and there are 3 temperature scales in current use. We have the Celsius scale, the Fahrenheit scale, and the Kelvin scale. These are the 3 major scales we have in use. This Kelvin scale could as well be called absolute scale. We shall be dealing with conversion among these 3 scales, because you can either convert from Celsius to Kelvin, you can convert from Celsius to Fahrenheit, you can convert from Fahrenheit back to Celsius. You can do every one of these. So this we're going to do now. You might be asked to convert from degree Celsius to Kelvin. We have this simple formula. To convert to Kelvin is our degree Celsius plus 273. So it's very, very simple. When you're given a value in degrees Celsius and you're asked to convert it to Kelvin, simply add 273 to the value, and that gives you your value in Kelvin. For instance, if you are given the value as 20 degrees Celsius and you are asked to convert it to Kelvin, what would you do? That's to convert 20 degrees Celsius. In Kelvin, it will be 20 plus 273, which is 293 Kelvin. So 20 degrees Celsius is equivalent to 293 Kelvin. This is your conversion between Celsius and Kelvin. The same way, you can see that if you're asked to convert from Kelvin to Celsius, you can simply subtract 273 from the Kelvin value and you get your value in degrees Celsius. When you're required to convert from Fahrenheit scale to Celsius scale, you can use this particular formula, which is very easy. Celsius scale is equal to Fahrenheit scale minus 32 times 5 over 9. That is simply when you are given your value in Celsius Fahrenheit scale and you are asked to convert it to Celsius scale. What will you do? You subtract 32 from the Fahrenheit scale, you multiply it by 5, divide by 9, and that gives you your answer. Example, if you are given or if you are told that the body temperature is 98.6 degree Fahrenheit, and you are asked to convert this to degrees Celsius, you simply use the formula which says that to convert from Fahrenheit scale to your Celsius scale, you simply subtract 32 from the Fahrenheit, multiply it by 5, then divide your answer by 9. So to convert this 98.6 degree Fahrenheit to Celsius scale, you will do 98.6 minus 32 times 5 over 9. 98.6 minus 32 will give you 66.6 times 5 over 9. So 6.6 times 5, we are given 333 over 9. This is simply, you can divide 333 by 9, and that gives us 37 degrees Celsius. So you can now see that while the body temperature is 98.6 degrees Fahrenheit, you can also convert it to degrees Celsius, where we get 37 degrees Celsius. You may be asked to convert from degrees Celsius back to Fahrenheit. It's also very, very easy. For the formula we had earlier, you can then make your Fahrenheit the subject of the formula. From here, we can now see that degree Fahrenheit will be equal to degrees Celsius times 9 over 5 plus 32. That is actually the simple formula to convert from degrees Celsius to degree Fahrenheit. So when you are given the value in degrees Celsius and you are asked to convert it back to Fahrenheit, use this formula. You put your value here, you multiply by 9, divide by 5, then you add 32. Let's say, for instance, you are asked to convert 20 degrees Celsius to degree Fahrenheit. So simply use the formula F is equal to degrees Celsius times 9 divided by 5 plus 32. So we are left with F is equal to 20 times 9 over 5 plus 32. 20 times 9 will give us 180 over 5 plus 32. So the next thing is 180 divided by 5. It will give us 36 plus 32, which is equals to 68 degree Fahrenheit. So simply, when you have put your 20 degrees here, multiply it by 9, which gives you 180. You divide by 5, which gives us 36. Then you add the 32, and you have your 68 degree Fahrenheit. So 20 degrees Celsius is the same as 68 degree Fahrenheit. So having known all this, you can still go further to convert so many of them, many values from Fahrenheit back to Celsius, from Celsius back to Fahrenheit. Alright, having been with me from the beginning to the end of this session, and I believe you must have learned how to convert from your degree Celsius to your Kelvin scale and to your Fahrenheit scale, and also to convert back. So try solving this so as to assess how much you've understood. Try converting 30 degrees Celsius to Kelvin scale and as well to Fahrenheit scale. I believe you can do it. Thank you so much, and I hope to see you in my next video, where we shall be solving some of your questions involving the thermometer and these temperature scales. Thank you.